Cool. So today is FQL. And today in general, what we're going to do is have an introductory lecture to databases and what FQL is. Then we're going to go through parts 1 and 2 of the workshop. Then after that, a live review going over those parts of the workshop. Then another lecture, then the part 3 of the workshop, and then a review. So that's today's schedule in general. FQL. You are going to be, this stands for Functional Query Language. And the plan is to build your own database management system in Node. And the goals, so this is what you're going to be doing, but I think the goals to get out of today is learn what a DBMS is, and today we're going to look at it from the inside. We're going to sort of learn how a car works by taking it apart and building our own. But another huge goal here is practice JavaScript. And so I think these two things, learn what a DBMS is and practice JavaScript, are like the biggest things to get out of today. So I want to start with some terms. So we've got a database, which is essentially a collection of persistent information. And it needs to be persistent, right? It also needs to be, let's see, queryable or accessible, however we want to call that. So, and then it needs to be, so let's call that queryable. And it needs to be organized. Cool. So these are the three properties that we should keep in mind for a database. And when we talk about a database management system, DBMS, that means a program that allows you to interact with the database. Cool. That's the general idea. And by interact, we sort of mean essentially query. That's the general idea. Some examples here that we can provide might be that you've heard of would be MySQL. And another one that we use a lot, Postgres, SQLite. There are a bunch of other SQL dialects out there as well. There's also something you may have heard of called Mongo, which uses document stores. There's Neo4j, it uses a graph-based database. There's React. Gosh, there's a bajillion more. And lots of small distinctions and large distinctions between all of them. But the general thing to keep in mind, I think, is that a DBMS is sort of, let's use an analogy down here. A database is like a spreadsheet, and a DBMS is like Excel. So the spreadsheet is just the raw information stored somewhere somehow. And a database management system is the thing that actually allows you to interact with it. Excellent. Now, the other thing I kind of want to go over here, because I think sometimes there can be confusion between some terminology, is a query language. So query language is the literal code and words we use to form requests to the database. A primary example is SQL. And today you're kind of going to be building all of these things in one. But that's a primary example is SQL. So its relationship between a database management system is that a database management system needs to support some kind of query language, which means it also needs to have something that executes, interprets that language. So when we talk about things like MySQL and Postgres and SQLite, these three SQL dialects all share the same query language, which is SQL, but they have their own SQL runtime. They have their own thing that executes SQL code. Excellent. So here we go. We have things that we're going to need about our database management system. Yeah. So these are things that a database has. Now let's talk about how we'll do it. How will we build our own DBMS. So any thoughts for this first one? If you need to store persistent information, do you know of any way of doing that already? If I told you that I needed you to take my name and my contact information and my date of birth or something and store it somewhere that it would be stored forever, what might you do?
I would write it down.
Yeah, good. Yeah, you could use a piece of paper, right? Okay, that's a perfectly valid approach. What if we wanted to make it accessible to a computer program? Where else might we store it?
In the directory?
Good. Yeah, on the file system. The file system. Okay. Achieve persistence via the file system. Okay. So now let's talk about organization. Is there any way that, like, just storing information on the file system is interesting, right? We would need, like, we'll need to put it in a file, right? But then how do we put it in a file? Like, let's say I tell you that my name is Omri and my date of birth is April 16th and my social security number is, you almost got me there. You almost got me. But anyways, how about I tell you this information? How are you going to, like, literally what is going to go into the file? Like, how is it going to be in that file? Any thoughts?
Text?
Yeah, good text. Beyond that, like, is it just going to be the first line is my name, the second line is my date of birth, the third line is my social security number? Like, how are we going to do this? And how do we know that the first line is my name?
Creating the table.
Yeah, good. Yeah, exactly. We need some structure to this. So what this is called is sort of a format, right? Via some format. And the format we're going to use is JSON. Which is essentially a way to format text or a way to format information. And let's get into JSON in a minute, but that's just one way we could store it. And I just want to fill in the last part here of what we had above. So we had queryable up here. So this is going to be queryable via JavaScript classes we write. All right, so there's actually going to be 3 different classes that we'll talk about more later, but there will be table, FQL, which is like a query interface, and there's going to be this thing called a plan. So before we go too much further on, I want to talk about this. I want to make this a little bit more specific. Specifically, we have a database already. So it's not up to you to make the database. It is a folder. And let me show you what that folder looks like. It looks like this over here, film-database. This is going to be in the workshop already there for you. And in that folder are other folders. And those things represent tables. So for example, we've got movies -table. In each of those folders are files. And let's go look at one of those files. They are JSON files. 0001.json. And those JSON files, if we look at one of them, here, let me actually split screen for a second. So if we look at one of them, those files are just like text, right? They're just strings. This isn't actually an object. There's no Java, like we're not saying console log this. So there's no JavaScript code here. This is just raw text. Those files are formatted in JSON format, but ultimately are just strings of text. Okay, so that's what we've got already. So that's how FQL starts. You've got this database, and now we need to figure out how to do this querying part. But this is how it all works, and we'll need to understand how to interact with the file system. We'll need to understand JSON to get a little bit further here. So let's talk about those things each in turn. First of all, FS. This is a built-in node library, or module, as it were, that has methods that for interacting with the file system. And let's look at an example. We should have seen this already, but I want to make sure that we're all on the same page here. We can do this. So this pulls it in. We don't need to install it because it is built in. And then we can do fs read file and give it some file that we want to read the text of. And it could be a text file, it could be a JSON file, it could be an HTML file. It doesn't really matter. It's just any file we want to read the text of. And then we get access to any possible error and the file contents. Here, let me toggle my highlighting on linting. So after that, inside this callback here is where we would do something with the file contents. Now, this is called non-blocking, what we see here. We use fs, we call read file, we give it the thing we want to read, and we give it a callback that will eventually execute with the result of this operation, with the result of the file reading operation. And this kind of asynchronous code can be tricky and awkward to deal with, and is not the focus for today. And because of that, because the focus for today is just getting more familiar with JavaScript in general, and again, learning what a database management system is, but not diving deep into asynchronous control flow, we are going to avoid it. And I'm putting this in all caps because I think this is an important part of the workshop. If you come into this thinking that you're going to use callbacks, you're going to have a bad time. We're not going to be doing that. The code above is not what we are going to be doing. Instead, we're going to be using the blocking methods. So that looks like this. We still pull in fs the exact same way, but now we do fs read file sync. And this part is important. This is a method already built into fs read file. It's not like you can just add sync to the end of any method to make it synchronous, but it is built into fs. It's an alternative. And we do the same thing, but now instead of some callback, we actually get the results as the result, as the return value of fs read file sync. So that means we do something with the file contents. And just to be clear, this is blocking. That means that no other code in our JavaScript program will execute while this file is being read. And just like in the callback is where we would do something with the file contents, now just the next line of code, line 49, is where we would do something with the contents. Any questions about any of that? Cool. Well, then let's go on to talk about my good friend JSON. So does anybody know what JSON stands for? It should almost be called John. which would be funny, but it's JavaScript object notation. That's what it stands for. And the S in JavaScript is going to be capitalized for this. So JavaScript object notation. And it is a text format. That's what it is. And it looks like, so that's why it's JavaScript object notation. It looks like a JavaScript object. And again, when we say looks like, all we mean is formatted like. So looks is formatted like a JavaScript object. That's all. It's still just text. And let me show you what I mean by that. Here's an example of some JSON. It would look like this. And an important thing to note is that this is a string. This is text. Like if I were to console log JSON string.a, what would I see? Correct, undefined. I'm going to assume that silence meant undefined in general, right? That we would see nothing. So undefined. And that's because this is a string of text. Now, if we wanted to convert this into an object, we can. This is not intrinsic to JSON. The thing what I'm showing you here is how JavaScript interacts with JSON. So there's actually a method in JavaScript called JSON.parse, and it takes a JSON string. And what that's going to come back with is something that we might call our data object. And this is going to be an object. Like if we console log data obj.a, we will indeed see 100. So this is how we can convert a JSON string. And remember, when I say JSON string, that's really just the same as JSON. This is how we can convert JSON to an object. We can also go the other way around. So we can convert an object to a JSON string. And that looks like this. So if we've got a data object from somewhere, and let's say it's now B50, just so we can see a difference between it and the other one, we could do JSON.stringify and pass data object in. And what would come back is our JSON string. And that JSON string, if we console log it, would look like this. Oops, accidentally pressed enter there. B50. That's when you say bingo. So there we go. That's what we've got. We've got a way to convert something that looks like an object but isn't. It's just a string that happens to be formatted like an object into an actual object, and a way to take an object and put it into a string that's formatted like an object. And very possibly, I hope, what might be occurring to you as a question here is why? Like why in any way would we ever do this? What is this useful for? And what it's useful for, it's actually surprising how useful JSON is. This seems like kind of a silly thing to be doing, but it's useful because you cannot store a JavaScript object in a file. A JavaScript object is this thing that exists in the runtime of your JavaScript program. It's this complicated. It's not something that you can just take and say, hey, put it in a file. On the other hand, if you turn this into a string is just a bunch of letters. You can take a bunch of letters and put those in a file. So that's the idea. Similarly, you also can, what am I trying to say here? You can also not send a JavaScript object to some other machine, like via HTTP, for example. So like if you've got some JavaScript data on one machine, like on your server, and you want to send it from your server to your client, you can't send an object. It's not possible. It can't be, again, transmitted from one place to another. But what you could do is convert that object to a string. It's almost like fossilizing it or something. So you take that object and you sort of fossilize it, or dehydrate it, maybe is a good way of thinking about it, into this string. And the dehydrated version can be transported anywhere because it's in a simple text now. It's just a bunch of characters. Then when those characters make it to the client, that thing will rehydrate it. It will parse it. So, so the whole point here is text can be stored in a file or sent across a wire. A connection, we'll call it. Okay, so that's the beauty of JSON. JSON is useful for sharing data between computers, and or useful for storing data onto the file system. Or anything that might be like either of those things. Again, anywhere where you need to say, I have something in my JavaScript program and it needs to get out of it somehow. Like it needs to go somewhere that is external to the program. Well, it should probably be converted into JSON then. So JSON is a format. Something I'd like to highlight at this point too is, well, you know, before we get to that, something I want to say is that this notion is called serialization. So converting data into a format that can be stored or transmitted is called serialization. So JSON is a serialization format. And I'll just actually, I'll put the other way around too. So converting converting serialized data, like a string really, back into a hydrated, we'll call it object, but it doesn't have to be an object because we're not at this point talking just about JavaScript. This is called deserialization. Deserialization. Okay, neat. So those are some cool terms to have under your belt. And JSON is a serialization format, but there are actually other ones. So there are other ones out there. So like XML is an example that you may have heard of. YAML, Pickle, I mean, the list goes on. There's not like there's a bunch more. So so these are all just ways that we could store text such that some other thing could be sent to it. So JSON is just one of these formats, and furthermore, JSON is not specific to JavaScript, and it is not only for JavaScript programs. And that's why it's called JavaScript object notation, not JavaScript runtime like serialization or something like that. So this is not just for JavaScript programs. We could have a Java server, say, that serializes its information into JSON, then sends it to a Python program that deserializes the JSON. Close enough. Yeah, I think that's about right. Deserializes the JSON string into its form of an object, which is a dictionary, which is a lot like an object. It's a key value pair. But my point is that JSON is just this generic format, and it was inspired by JavaScript objects, but that's it. It's usable really anywhere. And it's a very powerful idea, the idea that we can take any information and serialize it. So what we've talked about so far is JSON and the file system. And there are specific tools that you should be getting out of this, like read file sync, which is going to be important for the workshop. Parse, JSON.parse, which is going to be important for the workshop. And then there are larger concepts that have been important about just sort of how our database is stored on the file system and what that might look like, how that's persistent, and also just what JSON is in the first place. And this last thing I want to talk about, this is also going to be especially useful for the workshop. So I want to talk about class versus instance methods. And class methods are sometimes called static methods. Cool. So class versus instance methods. And this is, just like when we were talking about a second ago, not specific to JavaScript, this is an object-oriented idea. What I'm about, object-oriented programming idea. So again, this is not specific to JavaScript. It's also not specific to Sequelize. So you all have started Sequelize a bit as of Friday. You may or may not have seen class and instance methods in Sequelize, but when you do, realize that they're terms that Sequelize is just implementing as an object-oriented idea. It's not specific to Sequelize. So here's what it looks like in JavaScript, though, because we do need to talk about some very specific ways to deal with these. So if we have a car constructor that takes a license plate, and that's going to give us car A, then here is one thing we might have, accelerate. Cool. And here is another thing we might have, find by license, car, capital C car dot find by license, which gives us a 8J2L to match that one. And and this might give us the car we just found and whatever. So this, presumably this wouldn't be happening on the, these wouldn't be happening one after the other. This would be kind of silly, but these method would be called somewhere and line 90 would be called somewhere else. So I'll put some dot dot dots to indicate that. Okay, so great. So my question is, which of these, one of these is an instance method and one of these is a class method. So which one's which?
Find by license is a instance method.
Find by license down here is an instance method. And so that would make accelerate a class method. Cool. Yeah, reasonable guess. And you had a 50-50. Turns out it's the other way around. But that's totally fine. So this is, and actually I'll explain why it makes sense too, and why an easy way of remembering it. So, so this is an instance method on line 90, and the way to remember it is that it's a method, so accelerate, and the thing to the left of the dot is an instance. It's an instance of the class. And over here, find by license is a method, and the thing to the left of the dot is the class. So the difference here, like from a definitional standpoint, is an instance method is invoked on an instance, as in the thing to the left of the dot is an instance. And a class method is invoked on a class. And it's the same idea as above. The thing to the left of the dot is the class. Okay. All right. Now, this is at least what they are and what it looks like to invoke them. Now, how would we define them? So let's go into that. Let's use class syntax. So let's define a car class. And I'm going to give this thing a constructor. I'll start us off that way, which takes license and does this dot license equals license. All right. So that gets us at least as far as defining the class in general. So now tell me how we would define accelerate, this instance method.
Are we assuming that car A is still defined up there?
Oh, yes. We're assuming we have car here on line 102. Yeah.
Oh, I'm saying from line 88, do we have
car A?
Car A?
We don't have car A. We're assuming that like all of this code would actually sort of be after it, if anything.
Okay.
Yeah. It's like, this is how we would use the class if it existed, but we need to make it exist if we're going to talk about it.
And we want to define accelerate?
Exactly.
Okay. So you could do this dot accelerate in the constructor?
Yeah.
And it's a function?
Yeah, totally. So, and let's just define this as increasing the speed by 10. That's what acceleration does in a car, right? Always just increases it by 10. Okay, so this is one way to define an instance method. And that's probably an indication to you that there's another. And I want to talk about the other way. Does anybody know another way that we've used to define instance methods? I'll give you a hint. It's a thing about the JavaScript language that makes it somewhat unique. And about JavaScript classes in general that make them kind of unique and interesting.
This?
That's a good thought. Yeah, definitely this does. I'm thinking of the prototype chain.
Okay.
So we can also have accelerate as a prototype method. And the way you do that with class syntax, so if you say class car, we can just define accelerate here as like a, notice we're like inside the class definition here. We can define this as a method, an instance method by doing that. We can define it as a prototype method. So this is another way to define an instance method. And I want to talk about the difference between these in a second, but let's just at least note for now that this is on the prototype, and this is directly on the instance object. Okay, so accelerate, let's just fill it in with its definition here. Okay, excellent. Now what I want to talk about is something that I think is weird, find by license. So this might be the first time that you all are seeing and using a class method. And I'm going to show you how we don't define find by license, or at least as a class method. Line 115 would not work. We would, if we do line 115, let's just fill it into search license. So if we do line 115 for I is 0, while I is less than, okay, this is a little more complicated than I thought it was going to be, but that's okay. So we're going to have all cars, and we're going to all cars dot push the instance. So this is just me implementing find by license, that's all. So all cars dot length and I plus plus. Now inside of this, we're going to go ahead and say if all cars I license is the same as our search license, then we're going to go ahead and return all cars I. All right, cool. So either way, though, the way we have defined this is incorrect. We have put find by license on the capital C car dot prototype when we do it this way. So this would not work because the way we would have to invoke it then is car dot prototype dot find by license, which is just, there's nothing necessarily wrong with it, but it is unnecessary. And it's misleading because it makes it seem like find by license is an instance method. So instead, we want to put it directly on the class. And one way to do that is to just add the static keyword in front of it. Define a class. Because class methods are often called static methods. So if you see class method or static method out there, it's the same thing. They mean the same thing. So you just put the static keyword in front of it, and that means that it's now a direct property of the class constructor function, of the class object. And for reference, I want to show the other way. I want to show how we would do this in ES5. So this is ES6 with class syntax, and this is going to be ES5. So instead, with ES5, we would just define a car function, and that would now look like this. I'm actually going to comment out that way. I'm going to assume we're using the prototype way. I'll just leave it there. And now to define accelerate, we would do car.prototype.accelerate equals a function. And then on line, and instead of find by license, the way we have it, we would actually do capital C car dot find by license equals a function. So notice the difference here. In one case, we're accessing the capital C car dot prototype and adding a method to it. In the other case, we're accessing car directly and adding a method to it. So there we go. So this is how we would do this in ES5, or really just without class syntax. But these are exactly the same. There's actually no difference here. Okay. So any questions looking at any of this?
Well, I'm guessing you're going to get to it, so maybe this is a silly question, but what is the benefit of having a class method? Doesn't that constrict you more?
Yeah, good. So as before, like, what are we doing, right? Why would we bother with any of this? So, and specifically, why would we choose to, like you said, define a class method if we could just define instance methods only? So let's phrase that as, why do we choose? Why, yeah, why do we choose to define something as a class method as opposed to an instance method, or vice versa? And what does this all mean? So what are we doing here, and what are the relationships between these things? So I want to remind you that pretty much most of the things we do in programming are for human readability, and that's what class definitions are all about. All this class definition stuff, all of it, not just instance versus class methods, just defining a class in the first place. It's about humans, to help us understand our code so that we can read it, or maintain it, I guess, more effectively. Okay, cool. And so if that's our question, then all we have to ask to answer it is, what is a good fit? If we are trying to determine whether something should be a class or instance method, the question we should be asking is, what makes, like, cognitive sense, like to a human, right? Cognitive sense. So I'll get rid of this. What makes sense? All right. And I'm about to say something that's going to sound almost unhelpful, but then I'm going to expand on it further. So instance methods, we use them. They operate on a single instance. And class methods operate on, if you'll notice, potentially many instances, or sort of class-wide information is another way to think about it. So information that no particular instance has access to, but the class as a whole does have access to. And I said I was going to expand, and I will. So let's use an analogy here. So our analogy is going to be a car factory, because why not? And this is supposed to be, again, a real factory that we're imagining, no programming, like a car factory. And we're going to say that a car factory is like our car constructor. A car driving around in the world, that's like our car instance. Okay, so now let's talk about a car factory then. So a car factory might be able to look up certain cars it produced. I don't know. I actually don't know how car factories work, but let's say they can, by license plate. This doesn't sound believable to me, but let's go with this fictional universe. And this makes sense. I want to assert that this is a thing that a factory, as it were, can and should be responsible for doing. Because it has access to all the cars it created. And is a central point of information about any or all cars. So another way of thinking about it is that it makes sense, as it were. And that, when I say make sense, I don't mean that it has to feel simple at the moment or anything like that, but I want to assert that I think it makes sense, that this analogy kind of makes sense. That find by license is a thing a factory can do and that a car instance cannot do. And that means it should be a class method. So that's what it is. If something logically belongs on, is sort of a responsibility of the constructor, of the thing that constructs all cars, then it makes sense that it's a class method. Now let's talk about the other way around. It also makes sense that accelerate is a thing that a car can do and a factory cannot do, right? The factory is not supposed to accelerate when we press the gas. So it should be an instance method. That's the idea. Is something a responsibility of the thing we've constructed, or is it a responsibility of the thing that's doing the constructing? That's the question we want to answer. And so again, all of this is just for the sake of human readability. The whole reason we decided to go with classes as a thing in programming was so that people could sort of make believe, right? This allows us to pretend that this code here represents a car. Like we can then physically like almost envision a car when we do this and think about it that way. The whole point of classes and the object-oriented idea is that we can start conceiving of our code as objects that have some real analog. The objects that we're dealing with in our code have some realistic analog to what's out there in the world, or something that at the very least we can imagine and make concrete in our head. And so all we're doing with class and instance methods is continuing that analogy to say, well, certain behaviors are things that the constructor, the factory, will be able to do. And certain behaviors are things that have been created, instances, will be able to do. Excellent. So a little bit of a reminder of some stuff, because we've gone a bit of a ways away from where we originally started, but it is all very much related to what you're doing today. Now, what you have is there's this GitHub repo called functional-query-language. There's no learned out workshop, there's just this GitHub repo, and I'm gonna be sending out a link to it. Make sure to check out the README before you get started. And then from there, you'll want to check out the specs and the source. Film database is already there. So there's an existing database, like we mentioned, that is a folder, and the tables are other folders, and inside of those are .json files, which have text formatted like a JavaScript object. Your job is going to be to build this table and FQL and plan classes. So let me fill that out a bit more actually, because the table is going to be responsible for file persistence. And if we look at that, that means that the table is going to have methods like, let's look at this, like get row IDs, which will look up the file names in the folder, or where was another one? I think I missed it actually. Wait, where'd it go? Oh, maybe it's above it. Yeah, sorry, it's actually a bit above it. So there's also a read method, so table.prototype.read. So there's a read method so that you can access a certain object as data from the table. And this makes sense. This is one core part of what a database management system needs to do. It needs to be able to take data and persist it, and take persistent data and convert it, like persistent file system information, and convert it back into data that we need. So that's what the table is in charge of. FQL is this query interface, and it's in charge of things like, actually here, I have a code snippet that I think will help make this more clear. I'll add it below here. Here's what a query might look like. So we might do something like construct a new table, pass that table instance to FQL, and then do .select ID name, .where, .limit to, and .get, which actually executes the query. So all of this is to say, get the ID and name columns for all movies made in 1992, but only the first two. That's what this is saying. So what we're constructing here, this part, this select, this where, this limit, are all methods that the query interface is going to need to implement, and it's going to have the help of the plan. So this idea of a plan is that it holds information relevant to the query. Because the query has a lot to do. There's a lot on its plate to think about, okay, I need select and where and limit, and I need a way of executing the query. So the plan is going to help out a bit and hold on to certain information. As you go through the workshop, hopefully that will become more clear, but it is internal. It is not external. Notice that this is how we would use our query language, and nothing here makes any reference to the plan. The plan is just something that FQL has so that it can hold on to information and sort of make things a little more, split up responsibilities a little more. Any questions about the workshop? Cool. In Slack soon, I'll be sending out a link to the workshop, which is, again, just a GitHub repo. And I will also be sending out a tentative calendar, or sorry, calendar is the wrong word, schedule for today. Today, if you're not familiar, works like any other day in terms of help tickets. So if you have a question, make a help ticket, and myself or one of the fellows will be along to assist you. That's all.
Can you just break down what the plan's role one more time for me?
Yeah, I'd be happy to. The query is in charge of having methods like select, where, get, things like that. What's going to happen when you call select or where is the specs are going to tell you have select and where of FQL, of the query, call things on the plan to hold information. So the plan is almost like a post-it of like, hey, query, here's what you need to remember for later when you execute. Okay. So whenever a method is called in the query like select or where, or I don't think we have it, but you can imagine order by or limit, all that's going to do is say, hey, plan, here, jot down this information, and that's it. And then later when the query executes, the query will be like, oh, plan, I need to check some of that. I need to figure out how to properly run.
Okay.
Yeah. And it just so you know, this isn't something we pulled out of our hat. This is something that database management systems in general like to implement. They like to have this query language interface that before and or during execution has some kind of plan that corresponds to it.
Okay.